Hi all, welcome back. So this is Balakrishnan and I'm here to explain about the antivirus softwares, a complete technical breakdown of it. So let's start. So before moving into the actual content, let us look at some of the statistics in order to understand the seriousness of this particular issue. So the global cybersecurity market grew up to $40 billion in 2020. 76% of computers have an antivirus installed in it. 1 in 5 users have experienced a virus attack in the internet. Antivirus programs detect 350,000 viruses every day. Cybercrime has grown up to 600% because of the COVID-19 pandemic. Like you know, right? Like because of the COVID, work from home grew, and because of it, the cybercrime has also significantly grown up. So, and then the global antivirus software market alone has grown up to $4.25 billion in 2023. So 560,000 new malware pieces are found every day of the year. New malware pieces actually. Yeah. So how do they detect generally? Okay. There are like two main things. Okay. Any antivirus in the market, if you take either signature based detection and then behavior based detection. Generally, all antivirus softwares have a hybrid combination of these two things because one is a traditional way and evergreen technique, and another is the new age technique, I would say, which is the behavior based. Let us see a detailed discussion about both of them. Yeah. So the signature based detection, right? You can see it is the traditional method, okay, in order to identify and block the malwares and viruses. So this approach relies on the databases, okay. In the database, we have the malware signatures, and then the malware signatures are nothing but what? It is some unique patterns or the characteristics that can be found in the code or the behavior of the malicious software. Like generally what happens is that there are labs, okay, like Kaspersky lab or Avast lab. All these lab people generally what in those labs the actual diagnostic of the viruses and malwares take place, okay. And then what they do means they will take some specific patterns and characteristics. They will take those things and then put it in the database, okay, on the primary database. And using the internet, they actually share the signatures, the primary signature, to the end system of to our computers, okay, basically. And then our computers store in the local database, like local MySQL databases or like SQLite databases. There are many things, right? It stores in that, and then with that, using those things, it will actually match it and then detect. Okay, so what are the steps involved in it? First of all, signature collection, right? Security researchers and antivirus vendor collect samples of known malware from various sources such as infected files, websites, email attachment, and a lot of things are there, right? They will first collect all those infected. That's why they actually ask, actually in the agreement, right? Why you click like I agree and I agree to share. Why? Because like if it is infected, that infected file is required so that they can analyze and pick up the main unique patterns of that viruses or the malware. Okay, so the malware analysis is the next step, okay, are analyzed to extract the unique characteristics or signatures, as I told you, and this may include examining code, behavior, and other attributes of the malware. And then the third thing is the signature generation, okay, based on the analysis of what they have done on their labs. It is Kaspersky lab or Avast lab, whatever they do, right? So antivirus software generates signatures for each malware. Okay, those signatures are fed into the hashing functions, and then signatures are nothing but, see, whatever unique patterns you have found, you just put it into the hashing function and get a hash form of it. And then while comparing, right, while comparing in your system also, extract that particular text, put it into the hash function and compare the hash values, because comparison of hash values are faster, right? So we are doing a pre-processing of storing as well as computing everything in terms of hash functions. So yeah, so now let us see the signature databases, okay. So signatures are stored in the database with antivirus softwares, and then these databases are regularly updated. Yeah, exactly, we can see, right, like we will get like every day, like as per my knowledge, like Kaspersky and all, like every day it will ask for an update. Avast also every day the virus definitions gets updated. See, the exact software may not be updated every day. That software update takes like months or weeks, okay, weeks or something. But this virus updates comes every day. Especially like paid softwares get every day that virus definitions in the databases gets updated. And then scanning of files. So when a user runs a file or downloads it, the antivirus software scans for it for the potential threats in it. And then yeah, signature matching is done. As I told you, like the file's signature with the signature in the database. If the match is found, then it is a malware. If not, it is not. And especially these matches, right? As I told you, the signature matching is nothing but the virus signature's hash value is matched with the file's hash value. Okay, not the entire content, because matching of entire content takes hours and hours, which is like literally impossible. Like you cannot conduct that scan so fast, okay, within hours. So alert and quarantine, as I told you, like if the alert is found, then the thread is quarantined or deleted. Quarantine means like it is kept separate, okay, like it will be in observation, okay, so that it doesn't infect other files and the further harm will not be done to the computer. And then regular updates, as I told you, like we will be getting regular updates. The crucial is because new malware variants are created frequently. As I told you, in a statistics itself, we have seen that almost over 560,000 malwares are being created every day in a year, right? So new variants are being created very rapidly, so we need to update. And then heuristic analysis, as I told you, this is actually optional. That this is but included in the new age antiviruses. Like basically, like in order to avoid the zero-day threats, like the heuristic is that, see, there are some suspicious activity which are running or some patterns which are being seen means, then only those files are randomly picked and then scanned by the antivirus software. So that is the heuristic analysis. Okay, randomness. Then heuristic means especially randomness is that. Okay. And then the user education, like yeah, if you see certain antivirus software tells you that don't visit unnecessary sites, it has a browser plugin that comes with your browser, and then it will say don't visit kind of that way. It will just mark the trustworthy and untrustworthy websites. So what is the main downside of this signature based detection is that only the known, right? Only the known signature, okay, if the signature is known and it's been already detected, then you can find it. But if it is not there, if it's a new one, okay, or the update is not being made, then it is a big issue. It cannot detect it, right? It cannot detect it. It's a big cross. Okay, so therefore the modern antivirus softwares often combine the signature based detection with other techniques such as behavioral analysis, like machine learning, sandboxing. All these techniques, like these are the new age techniques. These are combined with this evergreen technique. But see, signature-based detection is an evergreen technique. It will never go out of the antivirus domain. Okay, it will always happen. The fundamental thing is to compare the signatures, compare the hash values, which is nothing but a comparison of signatures. Okay, so now let us see what is the behavior-based detections, how it happens, and like what are the steps involved in it. First is the data collection. Okay, the antivirus softwares continuously monitor the behavior of various processes and applications and files and on the computers. Okay, it collects various data like from system calls, API calls, file system changes, network activity, and more these things. It collects the data and then it analyzes the behavior. Okay, then baseline. Okay, there is a baseline. Okay, see, generally we will calibrate even a compass or anything. We will generally calibrate it, right? So similar way, first when a software is being antivirus software is getting installed, right, it will analyze the system's performance. Okay, what each software is taking, what the legitimate softwares are using, how much of the RAM, how much of CPU, how much of GPU, all these things are being used. It will measure. Okay, and then it will set a baseline. Okay, and then if something goes beyond the baseline, right, then there is some anomaly. It detects it. So let us see. The third step is that only behavioral anomaly detection. So the real-time running processes, any deviation from the baseline are flagged as potential anomalies. Okay, and these anomalies may indicate malicious activities or unauthorized changes. Okay, and then heuristic algorithms. As I told you, heuristic algorithms play a major role. Okay, because we can't see. There are two things. Okay, one is we cannot check every file. Okay, And another thing is that we cannot leave it also as such. Okay, so there needs to be some randomized algorithm which has some logic inbuilt in it also. Okay, it should not be completely random as well as it should not be completely illogical also. Okay, so these algorithms assign risk scores to behavior anomalies based on the deviation from the baseline. Okay, based on the severity, we will be acting upon it. See, there can be multiple behavioral anomaly detections, right? Like, see, sometimes you might have opened tens and twenties of Chrome tabs, right? When that happens, your memory is going to bump up like anything. Okay, but it is not a malware, or it's not some virus or some malware related activity. It's not like that, right? It's because of you, what you did it, right? So that time what happens is that the heuristic algorithms will help you. Okay, what it will do means it will assign a very least score for that particular anomaly detection. For that particular anomaly, behavioral anomaly detection, it will assign a very least score. Whereas an actual anomaly that is being created by a malware, it will give that an high score. Okay, that is how this heuristic algorithms plays a very important role in the uh, this behavioral based detection techniques. Okay, and then next is the risk assessment. As I told you, the antivirus software assesses the risk associated with each detected behavior anomaly. Low risk anomalies may trigger just warnings and monitoring without immediate action, and high risk may be like treated, and then it will like immediately tell you, like it will automatically even quarantine. In Kaspersky, it automatically quarantines. Okay, and then dynamic analysis is like what it does means. See, in dynamic analysis, basically, like you're running some gaming software or some game you're playing, right? Like let's say, okay, and then some suspicious activity is coming in, right? Okay, you cannot stop that game, right? Stopping the game or stopping the video or stopping the work is really is really like irritates you, right? It really irritates you from like the software itself will be irritating you. You will kind of delete the antivirus itself. Okay, so what it does, the new age antivirus is what it does is that it will take it to an isolated environment, which is nothing but a sandbox. Okay, sandbox is nothing but it's like a VMware, okay, virtual computer. Okay, if you have used VMware or Oracle's VMbox, kind of that way, in which you can create a system inside a system, right? It's actually not a new system. It is a virtual system. Okay, like it does not have separate hardware or something kind of that way. But it is actually a system with hard disk, CPU, GPU, everything being allocated to a certain extent. But it's a virtual environment. So doing in it does not affect your computer. Okay, it just affects that virtual box, which is nothing but that software, and it also has various code written to handle the edge cases. Okay, so it will put it into that, and then it will do all the analysis work by allowing it to run, and then it will start analyzing that particular software or the threat. It will start to analyze, and then it will log all the observations, and then it will say whether it is a malware or not. And then decision and response, as I told you, like from these things, responses may include like quarantining the file or terminating it, blocking the particular network. Like all these things are the response, okay, or the decisions. Okay, and then user activity. So if you see the user activity, right, user notification, right, it can allow, okay, like user notification is like it will always say, right, like some new thread is being detected, or some when you pen drive is being inserted, or when you connect to a new Wi-Fi connection, it should ask you to scan the network manually, because it should notify the user, and if the user says, it must do it. And continuous learning, as I told you, like the new age softwares are completely incorporated with machine learning and artificial. We will talk about this in the upcoming video, right? Like we will talk about it in a very detailed manner, how a particular use case it helps. And then cloud-based analysis, as I told you, like today everything is connected with cloud. Like all the threats that are being detected are like stored in the cloud, and then like on-demand updates are being given today. So what are the pros of it? Pros of it is it does not rely on signatures, right? So it can detect unknown threats. Okay, and then zero-day attacks can also be like detected. And then like, so because of this only, this is a valuable addition to the traditional signature-based techniques. However, there is a high false positive rate. Okay, there is some unacceptable false positive rate because see, what happens is as I told you, like even if it is not a malware, right? But it can be detected as if it is a malware because I have like personally also seen like my antivirus software, Kaspersky or anything. It is not at all a malware, but it detects it as a malware because it might have used some system files, it might have deleted some system files, or it would have done something. Okay, so that is treated as a malicious activity as per the rule book of the antivirus. So this is the overall flow. Okay. So if you see this overall flow, right, like you will receive the files from various sources, and then once you receive it, signature-based detection is being done. Okay, byte by byte. Okay, signature-based detection is like a time-consuming process, of course. It will check byte by byte, and if it is classified, then quarantine. If it is not, then unpack it and decrypt it, and then again classify it. Again, if it is not being found, then comes the second part, that is the block program behavior. Okay, generally we can just now only that behavior analysis should be done. Okay, with respect to three things. Okay, memory, network, file system. So it will do it, and then if some anomaly is being detected, it will again test it and then quarantine it. Okay, so what are the stages, right? Yeah, the first stage is that it when the file enters the system, in this stage like the malware detects it with the signature and then quarantines it. If it is not done, right, in the second stage, what we will do means we will just look into the software's log report, newly installed software's log report, and various other things. We will start analyzing it. Okay, and then what we will do means we will report if some particular wrong behavior has been detected. So as per the study, right, this is taken from one of the research paper actually. Okay, so as per this study, if you see means like almost 60 percentage right of the malware, okay, are being like detected within a day. Okay, but there are like antivirus softwares like around 4 to 16 percentage that have been detected within 8 to 30 days. Some are like taking even more than 30 days. Okay, the more the time this the malware exists in the computer, the more the risk. Okay, so but this is the one of the oldest data. This is 2011 data, so uh, I would say today it has been improved a lot. So yeah, and one more, this is one of the issue in the signature-based detection. Okay, if you see here, right, these are the virus families. Okay, these are the families of the virus. Okay, different families. But in the same families, you'll see in the orange family of the Trojan, PSW, Win32, LD, Pinch. In that itself, this particular threat is being detected in a very short duration, whereas this particular threat has taken a very long duration. Okay, this is one of the biggest issue because even though they belong to the same family, the decryption process and then the unpacking and the decryption process especially takes a lot of time. Because of that, what happens is that that signature detection is also a time-consuming process. As I told you, byte by byte checking needs to be done. So it takes varying time. Okay, so that is one of the shortcomings of this particular signature-based detection, I would say. Uh, yeah. So the block program behavior, as I told you, as we saw here, the block program behavior generally acts on four particular things, concentrates on four: files, registry, memory, network. So the malware functions often like they leave persistent copies of malicious code, right, in var, in the name of like install.exe, av.exe, like that. It will leave in the system files, and which we will click it, right, we will click on it, and then that will cause even more child files that are being created. Okay, which causes the spread of the virus in the whole system. Okay, so to mitigate this file system intrusion, right, AV software behavior-based detection impose restriction on certain system-wide changes, such as modifying or .dll files in Windows system. So these are attractive because these files are being consistently loaded, necessary for the other programs to run properly. So AVs prevent these programs from creating or modifying exe or DLL files in the system folders. Okay, and then registry files. So monitoring changes, if you see, right, see in this case you can manually do it, of course, But if something is automatically happening, right, then the antivirus should not allow it because it's dangerous. Okay. And then monitoring changes. AV software can monitor changes made to the Windows registry, as malware often tries to modify keys values to achieve persistence. Okay, unauthorized changes blocking. So if unauthorized blocking, it can prevent and alert the user or administrator. Quarantine. Malicious registry changes may be rolled back. Okay, we can roll it back. And maybe like the key value pairs can be quarantined. Okay, so this is how the registry is being saved. Then the memory. Okay, the process monitoring. It often checks. Okay, you can go to the task, right click and check on the task manager, in which the antivirus software generally keeps on monitoring your memory. Okay, suspicious behavior detection is there. Then, such as injecting the code or other process or accessing unauthorized memory areas, then the AV can immediately take an action by suspending that process. Memory scanning. Some AV solutions perform memory scanning to identify and block malware that resides solely in the memory. Sandboxing, again, as I told you, is nothing but it's kind of a virtual environment in which we can run the affected files or the files which are being like detected as affected, right? We can run it and then we can analyze its behavior. Okay, and then network firewall is there. The incoming and outgoing traffics are being completely controlled by this way. Like the incoming and the outgoing packets are there, right? They are completely having a control of it. If suppose some some affected packet is being coming in your line, right, then the firewall can immediately detect it and stop it. Okay, intrusion detection, as I told you, like while you're going out, you may be connecting to some networks and that some open Wi-Fi's, and that may cause some intrusion because there are some network commands that can be run and data can be easily thefted. So in order to avoid it, this is there. And behavior-based network analysis is like some AV solutions monitor networks behavior for some anomalies, such as legitimate program suddenly exhibiting malicious network activity. Like suppose say, generally what happens is that in order to do some things, so your data is being collected and kept aside. Once when you on the network, like turn on the network, a sudden surge of uploading will happen. Okay, so your network would be facing a lot of uploading bytes. Okay, so such kind of some malicious activities is been running, so that would be detected and then the AV will stop it from doing it. If suppose say some particular file, exe file, is been exporting constantly, is been uploading some data, then it will detect and it will stop it. And cloud-based analytics, as I told you, like cloud is involved because if cloud is there, then only real-time analysis can be made, because every particular analytics is, as I told you, it's time-consuming as well as it's intensive process. Okay, it's a CPU intensive process. It cannot be done on the local system. It needs to be done on the cloud. So these paid software such as Kaspersky, McAfee, all these people have labs in which they have a big servers. Okay, which can sustain this particular this particular thing, and then like what it can do is that it has a capability, right? Like the system power is more, so it can run these processes, that checking byte by byte checking in the signature, all these things against like millions and billions of signatures. It can check with this database within fractions of second, right? So cloud-based analytics is one of the very important thing. So how the new age AVs use AI? Let us see. Okay, like now we have seen this buzzword, right? The AI, ML, all these things. But it's not buzzword. It's actually being used in the cybersecurity field, especially in the antivirus field. Okay, I would like to take one particular example. Okay, one particular example and explain it, because if we go in general, it doesn't make sense. Okay, instead of that, we can go with one particular use case and then we can crack it out. So let's go with an example. As I told you, yeah, we can take the zero-day threat detection, okay, and illustrate how AML can help to detect previously unknown and highly dangerous malwares can be detected. So let's see. So the explanation is that the zero-day threats are vulnerable or malware for which no signature or pattern exists in the virus database, right? The traditional will, of course, it will fail, right? So, however, zero-day attacks means itself like no patterns and making them a significant challenge. Okay, so this is the explanation, and let's see the example. So let us consider a real-world scenario example: the zero-day threat. A cyber criminal has developed a new type of ransomware, okay, and released into the wild. Okay, so this ransomware is designed to encrypt the victim's files and demand for the ransom for the decryption. Okay, we have seen it, right? We have read it in a lot of news, like in 2020 and all. Like a lot of ransomwares are there which are encrypting the important office files and then demanding money in Bitcoin. If it is being paid, then only we will like give you the decryption algorithm, which is a very hectic thing, right? If backups are not there, then it's a big headache. So yeah, so the traditional hardware without AML, like it cannot detect, right? It cannot detect this new thing. It is not even in the database also. So what you will do? You cannot do anything. And also there is a big risk, right? The more you are allowing it, okay, to stay in the system, right? The more the time you are allowing it to stay in the system, the more number of files will be encrypted. And if more number of files are being encrypted, then of course you will demand a lot of ransom, and then like without paying ransom you cannot decrypt it, and like it's a big headache. So how this will help, let's see. Like see, in AML, if that is being like it will analyze the behavior of the new ransomware even though it has no signature, no known signature. ML models have been trained on the vast data sets of normal and malicious behavior. Okay, so they can identify anomalies and patterns that deviate from the typical system activity. And when new ransomware begins to encrypt the files, the AI component of the antivirus identifies the unusual behavior of rapid mass file modifications. Okay, the rapid mass file modifications is the key here. Okay, and flags it as a suspicious. Okay, so the antivirus can then take an immediate action to stop the ransomware. Okay, see, two things to importantly note here is the ML model. Okay, what is an ML model? ML models are nothing but a model that is being trained on a vast data. Okay, so that the ML model now looks into like billions and billions of data and now understands a pattern and creates a pattern in that particular data. Okay, like y is equal to mx plus c, like that, like how various points connected together makes a line. Similar way, ML model also goes through a lot of signatures and lot of behaviors, and then it identifies which is the correct behavior, which is a anomaly behavior, which is a wrong normal one, and which is a abnormal one. It actually identifies it, and then based on that identification, right, based on the trained model, right, we have now the trained model. Now if you input a new data based on the trained model, based on the pattern, ML model will now tell you whether it is an anomaly behavior or not. So now that is the AI component basically. So but that is being embedded with the antivirus software. So now when an antivirus software usually has some rapid mass file modifications, see, this you cannot always say that when sometime like rapid mass file modifications are happening, then it is antivirus. You cannot tell that, because see, even you can do some particular activity, right, like copy pasting, transferring of files into your backup disk. All these things also makes mass file modifications, but it is not a malware activity. In order to detect whether it's a malware activity or a user activity, the ML model helps you. Okay, ML model comes in and it helps. It will, based on the data on which it is being trained, it would tell whether it is a activity, correct activity or not. And based on that, you can act upon it. So what are the key benefits? As I told you, yeah, it does not rely on signature, more adaptive, more responsive to the emerging threats, and ML model can continuously learn from the new data and improving their ability to detect even more sophisticated threats in the future. Say, see, you're also facing some ransomware issue, like 10 other people also facing it, different ransomwares. Okay, like billions of people around the world would be facing this issue, right? So now that billions of data is being collected by the antivirus team, say Kaspersky or McAfee does it, they collect it and then they retrain the ML model with the new data. Okay, so now the ML model is now even more equipped. Okay, now it can easily detect it, okay, which is a ransomware, which is not. The accuracy of the ML model now it bumps up. Okay, the AUC scores also goes up. The F1 score also goes up. Okay, now in summary, like 0 to 8 threat detection powered by MAL is a critical use, of course. So that is why like all the antivirus leading partners like Norton, 360, Avast, Kaspersky, name it anything. Every particular antivirus software maker is now embedding AI/ML in their product. So one of the key references, like the initial things with whatever I told, was taken from this particular research paper. Basically, this is a IEEE published research paper. Basically, these are the publishers. They are from Carnegie Mellon University. So basically, from this paper only, I have taken a lot of data, commercial antivirus software effectiveness, and an empirical study. So that's it. Thank you. Bye.